All right, I think I'm live. Hey guys, how are you doing? How is the indie game engine development community doing today? Um, Today I want to talk about how to implement game entities, um, especially to everyone who is new to game engine development. You guys may be wondering how to start implementing your game characters entities. It's not that hard, but if you're new, you may be wondering how to do that. So I want to talk about that today. However, before I begin, if you haven't subscribed to my channel, please do so. And if you haven't joined my Discord server, please do so. I'm going to provide a link in the description below, so that way you can join. All right, and I think I forgot to provide the link today. So after the live stream, I'm going to do that. All right, guys. So let's begin. Let me see if I have everything set up. All right, so we're going to talk about basically how to start building your game engine, and more specifically about game entities. All right, so let me see if you go. I'm here now. All right, so let's talk about a game character, for example. I think that's the best place to start, so you can get an idea of how to implement everything else, the whole architecture. So you know that a game character is supposed to move around the scene, is expected to collide with other objects. Hey, Greenblade, how are you? Um, a game character is also expected to, to have some animation, some walking animation, some running animation, etc. You are expected to, to control the character, right, with your with the mouse or the joystick, or the controller. I'm sorry. So, how do you go about implementing all of that, right? So, there are two ways that you can do this, right? Number one, you can implement the whole game character in like on one class, and and have that class responsible for all of the behaviors. All right, Grimblade. No worries. Just let me know. I think I'll be here like for about 20 minutes also, so it's not gonna be a long stream. All right, so as I was saying, how can you implement that whole game character entity, right? You can either implement it in one class, and have that class be responsible for all of the behaviors such as motion, animation, collision. But you don't want to do that. That is not the right way to proceed when you are developing not only a game engine, but basically any other application, right? The most recommended way that you should do is to break all of the behaviors into different classes and have one class be responsible for only one and only one behavior. For example, here I have one class that is going to be responsible for the local space, for the absolute space, and the transformation of the character. I have another class that is going to be responsible to be communicating with the with the GPU and the render manager. I have another class that that's going to be responsible for basically acquiring all of the attribute data of the character. I have another class that's going to be responsible for any dynamic behavior, such as when you apply a physics. Such as when you apply a force to an object, how is that object going to be moved because of the force, right? And I have another class that is going to be responsible for all of the collision behaviors, right? Whenever it collides with another object. So if you divide all of the classes like this, you are going to be able to basically have a more modular architecture in your game engine. So let me show you how I implemented a game character entity in the Untold Engine. All right. So the first class that I have here is the root class. This is the main class where everything else originates from. All right, and it is essentially that like the root class, but in the Untold Engine I call it that U for the entity class. And as you can see here in the code snippet that I have, this class will hold the data that contains the local space of the character, the absolute space of the character, and also the transformations, such as when you want to rotate the character, translate the character, on and on and on. Obviously, this class has more stuff to it. I'm just highlighting the most important parts of it. So this is my my root class, the U4D entity class, right? Next, I have my visible entity class. And this is the, I call it a U4D visible entity. And basically this class will inherit everything from the U4D entity class, everything from the, from the root class, and will expand the behaviors, right? And the whole purpose of this class is basically to communicate with the render manager, right? It's going to basically tell the manager, what to render on the screen. It's going to inform the render manager the type of data that the character contains. For example, does it have an armature? Does it have textures? Does it have obviously normal vectors, etc.? But this class is basically responsible for communicating with the GPU. That's the whole responsibility of this class. So just to recap, the first class, the U4D entity class, is responsible for holding the local space and absolute space data of the space of the character. And the visible entity class is responsible for communicating with the GPU. Next, I have my 3D model entity class, right? And again, this class will inherit everything from the visible entity class. Why does it inherit everything from the visible entity class? Well, because you are expected to see the entity, right? You are expected to see the model on the render on the screen, right? So it inherits everything related to local space, absolute space. It inherits everything related to communicating with the GPU, and it expands some more behaviors, such as containing data related to the body coordinates of the 3D model, such as the vertices that make up the whole character, the normal vectors that make up the character, the UV coordinates data. It also contains some material information, such as what I'm highlighting here. It also contains texture data, texture information that you want to know, and bone armature. Especially if your character has some animations, it's going to need the armature data to be able to animate. And I have some polygon information here that I use for other purposes. Right, so that's how I build the 3D model. But it doesn't stop there, because then you also want your character to be able to collide with other objects, right? And for that, I have another class responsible for that, right? This class will contain convex hull data that you need, especially when you are using the GJK algorithm. It requires the convex hull data to do the computation. I also have the sphere bounding volume data, which is basically the data required in the first phase of a collision detection. And I have some mass properties, right? And collision properties. For example, you will want to know what are the collision points, the contact collision points, and the normal force vector that happened during the collision. So I have all of that data in the U4D static model class. Now that's the static, right? But now you also want it to move, and that's what how I implement the dynamic entity. And the dynamic entity basically is in charge of storing all of that data related to velocity, acceleration, force, everything related when a force is exerted onto the object. This is the class that is responsible for having all of that data. And finally, I have my game object entity. This is basically my character, right? And this class will inherit everything from the dynamic model, from the static, from the U4D model, to the visible entity and all the way to the actual root entity. So my game character has data, contains data related to my local and absolute space. It knows how to apply transformations. It communicates with the rendering manager. It contains data related to the vertices that make up the whole character, and textures and normal vectors, etc. It contains, it also inherits data related to collision. In this case, my static model will contain data related to the convex hull, bounding spheres. The dynamic will deal with everything related to the physics that is exerted onto the object. Any forces exerted onto the object, it will be taking care of that. And then I have my U4D game object, which is my character, right? So when you create a game object, a character in the Untold Engine, basically, just like I mentioned before, it will inherit all of these behaviors and properties from the parent class. So that's how I basically implement the Untold Engine, right? Now, why do I do it like this? Why not do everything in one class? Well, because you want to make sure that your game engine is very modular, right? And a good example is something like this. For example, my U4D entity, like I mentioned, holds local and absolute space data, and also transformation operations, right? Now, not every entity in your game engine is going to be rendered, right? And a good example for that is the camera, right? Your camera, you don't even see it in a game, and you are not going to see it at all. So it doesn't make sense to inherit any behaviors or properties related to the visible entity, which communicates with the GPU, right? All what you really care about a camera is the position, the local space, the absolute space, and how to rotate it and translate it, right? That's all that you care. So you don't need to communicate with the GPU. And within, and if you have some entities that are required to be rendered, not every entity is going to require collision detection, or they are not going to interact with any external forces, right? So you want to split them up, right? So for example, I have my particle system here. You do want to render the particle system, but it's not going to have any any vertices or any normal vectors associated with it. It's not going to deal with, again, collision. And you can also have, images, right? Images are just, you only want to render them, that's all. And you are going to treat them differently as when you treat you for the game object, a game character. And the U4D image will basically be the parent class of sprites and U4D fonts, and each of these classes will require different properties, right, from any other entity. So that's the way how I have implemented the Untold Engine. Basically, I basically follow this rule, right, that one class is responsible for one and only one thing. I don't have a class to be responsible for, for rendering and for doing transformations at once. I don't have a class, that is responsible, for collision and using also, collision and also, I don't know, like doing any things related to animations. I don't have that. I have everything is basically modular, like Lego pieces, right, that you can later on just put in together. So that's how I implement the Untold Engine, and this is obviously how I did it, but you may have a better way to do it. You may have a better way of how to architecture this whole flow, and that is okay, because that is the cool part about game engine development. You are really free to do whatever you feel like it, right? If you feel that this architecture or how I'm doing it right now is not the correct way, great. I feel it is, but if you have a better way, actually let me know. How will you do? How will you implement all this? Um, you know, uh, just write a comment in the section below and let me know how you will do it, and we can discuss it. But this is how I will do it. I essentially follow this one rule. Um, that a class is responsible for one and only one behavior. Actually, if you want to know how I actually, my whole, how I approach, how I approach game engine development is by following these 7 principles that I have here. Actually, let me look it up. I'm gonna go to my website right now, and there is this infographics that is really cool. 7 principles of, should be coming up. Boom, this one. The 7 principles of object-oriented programming, and these are basically, what I follow, the rules that I follow when I'm developing a game engine. Principle number 1, encapsulate whatever varies. Principle number 2, code to the interface, not to the implementation. Principle number 3, favor composition over inheritance. Principle number 4, strive for loosely coupled designs between objects that interact. Principle number 5, this is a big one, classes should be open for extension but closed for modifications. Principle number 6, depend on abstractions, do not depend on concrete classes. This one is also a really good one to put into practice. And principle number 7, a class should have only one reason to change. That's actually the principle that that I follow when I was implementing the whole entity architecture. That a class should have only one and only one responsibility. So that's how I do it. If you have better ways of how to do this, do let me know in the comments below. I would like to hear that. I tell myself everything about how to develop a game engine, so I may be wrong on how I did it. I'm pretty sure there are better ways to do it, but this is how I did it. But I'm always open to learning, new concepts, like new ideas, better ways to implement a game engine. So I'm eager for you to let me know. And if you are new to game engine development, I hope this actually helped you, at least to give you an idea, a direction on how to proceed, on how to implement a game entities in your game engine. So yeah, if you haven't done so, please subscribe to my channel and join my Discord server. I'm going to provide a link in the section below, and we can have a discussion there on how you would do a game engine, right? How will you implement your game entities? What's the best way to do so? So please join my server. We are a community of indie game engine developers that we like to help each other. We give tips, advices, and it's like a safe place for anyone, right? Either if you are new, just feel free to come into and ask whatever you want to ask related to game engine development, and don't worry at what stage you are in, right? Again, it's a safe place. If you are completely new, just ask. If you don't know anything about OpenGL, ask, and either me or anyone in the server will help you with that. And if you are an expert, also join that Discord server, because we do need your knowledge, so we can share that with everybody else. So that is all what I wanted to say today, guys. Thank you for joining my live stream. Again, don't forget to subscribe to my channel, and I'll see you next time.